All right, as we talk about conic sections, the fourth one we're going to talk about is actually an old one. It's the parabola, and the only difference is now that we're going to allow parabolas to open side to side and not just up or down, because now these relations don't have to be functions, and a sideways opening parabola is not a function. Before we get to some of those, let's talk about the definition. A parabola is all points that are equidistant from a point called the focus and a line called the directrix. And we found these two things earlier when we were talking about quadratics. Every point that lies on this curve is the same distance from this line as it is from this point, and join all those points together, and we get this U-shaped graph that we call parabola. Just to remind you how we found these, this little distance between the focus and the vertex and the directrix and the vertex, that distance is 1 over 4a. And 1 over 4a is, and that a is the leading coefficient of the quadratic. So in our case, that's 1 over 4 times a half, which is 1 over 2. So we can see in this one that that distance is a half a unit. And that's how we used to find those 2 points. We'd find the vertex and add and subtract that amount to get the point and the line. And like with everything in parabolas starting now, this can be in the x or the y direction. Here's the first example. And we're going to find vertex, focus, and directrix of this quadratic. And you'll notice that x is alone on the left, y squared plus 10y plus 23 on the right. That means this is a sideways opening parabola. Basically, we've switched x and y. But to find the vertex, focus, and directrix, we're going to use basically the same steps. I want to put this thing in vertex form first by completing the square. And if you have y squared plus 10y, the constant that's going to make that happen is 25, because half of 10 is 5, squared is 25. And I had a 23 there, and if I want to change a 23 to a 25, basically I'm going to break it into 25 minus 2, and then write the completed square. Y plus 5 squared minus 2. So the vertex, remember how in the inside parentheses we used to take the opposite of that number? So the y coordinate of my vertex is negative 5. The x coordinate is this number, negative 2. So we're going to have a vertex at negative 2, negative 5. I'm just going to kind of sketch that to get an idea when I'm looking for vertex and focus. Negative 2, negative 5, somewhere down here. And this is a sideways opening parabola, and it's positive. So if that's the vertex, it's going to look approximately like this. And just having that sketch gives me a better idea of which way I should add and subtract this quantity to get the focus and the directrix. A lot of our parabolas end up just having a leading coefficient of 1. Just naturally that happens. So 1 over 4a in this case is just 1/4. That means this distance from the vertex to these two features of the graph is 1/4. The focus is always going to lie right inside the curve of the parabola. And that's 1/4 of a unit to the right of negative 2, negative 5. So instead of negative 2, negative 5, and negative 2 would be negative 8/4, I'm only going to go negative 7/4 and then down 5. So here is my focus. And then my directrix is this vertical line, right? X equals, and that's 1/4 of a unit to the left of my vertex. My vertex has an x coordinate of negative 2, that's negative 8/4, and I need to go to negative 9/4 to get the directrix. So again, things you've done before, but you did them with a quadratic function that opened up or opened down. The math is the same, just remember everything is reversed in terms of which one's x and which one's y. Okay, and here's our final example. We want to be able to work both ways. I'm going to tell you the focus and the directrix in this one and ask you for the equation. Again, it's nice to have a little sketch just to kind of visualize what we're working with. 3/4 2. So there's a half, 3/4 is about here. Here is my focus, 3/4 2. The directrix is -35/4. So 8 would be 32/4, and 9 would be 36/4. So this is -8 3/4 x equals. That's the directrix. So again, this is a sideways opening one. As soon as I see a directrix of x equals, I automatically know this thing opens left or right. -8 3/4. There's -8 1/2, 8 3/4. So here's my directrix. So if you're writing the equation, there's really two things you need to know. You need to know the leading coefficient. We're going to write it in vertex form, which we could then change to other forms if we needed to. But you need to know the vertex, and you need to know the leading coefficient, which is a measurement or which will determine how stretched or not stretched the parabola is. We're going to start with the center. The center is going to be right in between the focus and the directrix, and it's going to be right here at -4 2. -4 2. That's, you can kind of visualize that. That's got 4 3/4 units right here, and it's got 4 3/4 units right here, but it's right in the middle, and it's on the same height of y equals 2. So I can kind of get an idea. My parabola is going to look like this, curving away from the directrix. And I've got most of the equation already. I'll kind of write the equation up here at the top. In vertex form, this is an x equals. I don't know this leading coefficient, but I do know the x and the y coordinates of the vertex. And remember, they're switched. So inside the parentheses, I need the opposite with my y. I need the opposite of this y coordinate of 2. So y minus 2. And then -4. Okay, it's easy to reverse those when you're talking about sideways parabolas. You're so used to doing this with a function that sometimes those are easy to mix up. But make sure you understand that y minus 2 is in parentheses because the y coordinate is +2, and -4 is the x coordinate, so we end with a -4. I used to always say opposite of that and not opposite of that when we were trying to find the vertex. It's what's going on here again, just in the other direction. So now all that's left to do is figure out this leading coefficient. This one's going to be kind of an odd one, but remember, 1/4a is the distance between vertex and directrix, vertex and focus. And we talked about how that was 4 3/4. 4 3/4, that's 19/4. That's 16/4 plus 3/4, which is 19/4. So that distance is 19/4, meaning 1/4a is 19/4. Multiply both sides by 4, you're essentially going to drop the 4s, and I get 1/a equals 19. That means a is 1/19. So that's all that's left to fill in, 1/19. So kind of an odd one. If you're going to have any distance between the vertex and the directrix, vertex and focus, you're going to have a fractional, a small number out front, less than 1. Otherwise, they're kind of really pinched in closely together. But there's how we're going to take focus and directrix and turn them into an equation.